Okay, what we have is our K5 tender chassis on the table here, and it's wired in with clips and stuff. I didn't have a chance to get it into the thing, but if I did, you wouldn't see it. I haven't built trucks for it yet, but I will. I've just got it wired into my transformer. This is the old number 2, good old boy. We're running our controller, motor controller board, and it's running this AC motor that's been converted with magnets to DC. And this is flyer smoke. See the piston, right? And you see the stick with a hole in it, and then the smoke's coming out. Got a leak in my lid here, but I'm working on it. But it does have a different lid on it. This is a lid that is it controls the heat a little more. So here we are at low speed. We're still putting in almost 7 volts to the heater. And as I speed up, I still have that 7 volts, so I'm getting a lot more. In fact, it's increasing the heat because I'm blowing more air in. The faster I go, the more energy it gets because it's blowing air. Boy, I gotta fix that leak. That really destroys it, doesn't it? But as you can see, we're smoking, and I'm going to go to neutral. Now I'm going to go to reverse. Well, I was in reverse. My apologies. I'll go to neutral. Now I'll go to reverse. Ah, I told you. Okay, so, and smoke is there at low speed. Nice smoke, 6.7 volts. It's getting hot, so it's going to cool down a little bit. It's an 18 ohm resistor in there. It's the angel hair from below with smoke oil and the same stuff. I just took everything off the lid and replaced it with some electronics, okay? Minor, very tiny. You can see it's like 4 parts, okay? But it gives us a regulated 9 volts in, and then it regulates the heat to a temperature so that it doesn't overheat and burn out the coil. But it also maintains the heat at low RPM, low voltage on the transformer, and good voltage at the heater. And then as I speed up, it doesn't take 16 volts to the heater. It stays at under 7 volts to the heater, so it's not going to overheat and burn off the oil faster or over smoke the room for mom, or burn out the coil. So that's the reason why I do the smart smoke lids. The DC conversion on that is for convenience more than anything. I hate having to wire an AC motor when we have digital electronics for digital reverse. So this will fit inside here. Only it goes this way, yeah. This will fit inside here. The wiring will go forward. Right now it's 4 wires. I can wire the light either into the motor or into this 9 volts coming in. If I use an LED, I can use 9 volts coming in. And I already started an LED in this. In fact, I already converted this to LED. So I could clip this on right now and it would light up. Ha ha ha. So there. So now 4 wires coming in, so you could use that same thing. And here we are. And there's full speed. We're working on a faster speed. I don't know if we need it, but we're working on it. Neutral and reverse. Or forward. I was in reverse. I get it wrong. It doesn't matter. It works. The trick is reverse works fairly just exactly like the old Lionel 103s, only this one is a lot more robust, runs a lot cooler, and we've got a spare. We've still got our power distribution panel only because of the heat pulling on the heater, the smoke pulling off of this machine makes it run hotter. If you're running all that voltage through one board, I split it here, so I've got 2 rectifiers, 2 distribution panels, and so the smart smoke is getting its power independently. It's off in the track, but it's not linked into this control board, so the motor control is on its own. It can go fast. The smoke will be on its own, and it can control the amount of smoke based on temperature, based on air blowing by, not speed. Now it's going to get hot because we're going slower, so it cuts back on the temperature. If you see that 6.3 over there in the corner, that's the voltage dropping. It has a fixed 9 volts coming to it. Fixed. So whatever is going up and down over here is not the throttle, it's the board doing its magic with the thermistor and the regulator inside it. Okay, so there's your low speed smoke. Crank it up a tad. I could boost the voltage, maybe it's about 8.8. I could bring it up to 8.9 or 9.0 on the dot, and you get a little better smoke. But as you can see, when it cranks up, you got no problem with smoke. It doesn't run out. You're not over smoking either because you're not going past, look at that, 6.8 volts. That's good smoke. Not too shabby. Not too shabby. Okay, so we're really close. I got to get my tenders built. And these tenders, I shut this off. These the trucks are designed to bolt right into this chassis. So I ran out of metal chassis for the K5. I just didn't have any. So I just printed one. I'm going to put my trucks on here, the all-wheel pickup, right? All-wheel pickup. 8 wheels are brass or steel. They pick up power. Never run out of power on the track. And it'll be bolted to this 3D frame. It's isolated. That's a good thing. There was one thing about that. Oh, the mass. This is a heavy tender, not a problem. But Jim and I were talking just yesterday about adding some metal under here, some steel, thin but wide, to give it a little more mass and make sure it's stable. Okay, gang, that's it for now. It was a fairly okay day. I built this guy real easy after building some of these other boards, and I've got it wired up, and this is how this is going to go together until we come up with something different later, which we may. Hard to say. I got to put some lights on this thing, wire that headlight up, and we're golden. Okay, I'll pop this up, and I gotta go take out the garbage. Man's got to do everything around here. All right.